How can I make a cloud form in a bottle?
Note, this experiment involves fire and flammable materials. Adult supervision is a must. Chemistry principles encountered in this experiment: ideal gas law, phase changes, droplet formation, materials you'll need: 20 ounce or 1 liter plastic soda bottle, warm water, 1 to 2 ounces. Matches the procedure. Add warm water to the soda bottle until the bottom is just barely covered with water. With the bottle tipped so that you don't burn yourself. Ignite a match and insert the burning end of the match into the bottle. Allow the bottle to fill up with smoke. When the bottle is fairly filled with smoke, or when the match goes out, remove the match and screw the cap on to close the bottle. Clouds will form when water vapor forms small but visible droplets around particles in the air. In this experiment, the smoke will provide these particles around which the water can form small droplets. With the bottle closed, squeeze it several times. You should see a cloud form when you squeeze the bottle. The temperature of the gas inside may temporarily increase, but the temperature will quickly equilibrate with the surroundings. Recall the ideal gas law we discussed in Atoms and Molecules, PV equals NKBT. When you release the squeezed bottle, the temperature inside decreases, cooling the water vapor and helping it to liquefy into droplets on the particles provided by the smoke. This is very similar to how real clouds are formed in the atmosphere.
Why did they, Theodor Svedberg, Sweden, win the Nobel Prize for Chemistry?
For his work on disperse systems. Svedberg's disperse systems were, like the previous year's winner, colloids. Svedberg studied their absorption, diffusion, and sedimentation. He was able to produce colloidal particles to validate Einstein's theory of Brownian motion. To accomplish this work, he developed the ultracentrifuge, which he used to purify proteins. The unit used to describe the rate at which particles undergo sedimentation is now known as the Svedberg. 1 Svedberg equals 10 to 13 seconds equals 100 femtoseconds.
What is a centrifuge?
A centrifuge is a machine that spins its contents very quickly and is used to separate the components of a mixture. The rapid rotation applies a force that causes the more dense components of a mixture to collect on the bottom of the centrifuge tube and the less dense components to rise toward the top.
What is a band gap?
The energy range separating the top of the valence band and the bottom of the conduction band in a semiconductor.
What is a triple point?
The combination of temperature and pressure values at which solid, liquid, and gas phases of a substance are in equilibrium.
Why are lasers useful for physical chemists?
Chemists use lasers to study how molecules interact with light. In some cases, a chemist may want to know how a molecule reacts when a pulse of light is used to excite it. In other cases, lasers can be used to gain information about the structure of the molecule. One of the reasons lasers are good for these purposes is that they can provide pulsed light to gain information about how molecules are changing over time. Another is that many tricks exist for controlling and manipulating the wavelength of the light produced by a laser, making them versatile light sources.
What is biochemistry?
Biochemistry is the field focused on elucidating and explaining the complex chemical processes that take place in biological systems. It's a diverse field, drawing on aspects from virtually every other subfield of chemistry to explain the molecular processes that drive living things. Often, biochemists study complex reaction sequences and catalytic processes involving molecules much larger than those routinely encountered in other subfields of chemistry. A few topics commonly encountered in biochemistry include studying how our cells obtain energy, understanding how our genetic material, DNA, dictates who we are, and explaining how our body regulates and stores nutrients from the foods we eat.
What are the potential dangers of nuclear energy?
The main risks associated with nuclear energy have to do with health hazards of radiation poisoning. This isn't the same type of radiation we're talking about with light and microwaves. That type is electromagnetic radiation. The radiation associated with nuclear energy involves subatomic particles, like neutrons, given off from nuclear decay processes. Exposure to this type of radiation can cause cancer or genetic defects, among other problems. Since the fission processes used to generate energy are normally well controlled, though, nuclear energy is generally one of the cleanest energy sources available. Nuclear reactors only become dangerous in the event of a meltdown or other disaster. But the chances of these happening are extremely small. Modern nuclear power plants are built with a series of fail-safes such that a series of multiple extremely unlikely events would have to happen, one after another, for a meltdown to occur.
What is an alkali earth metal?
Group 2 of the periodic table, i.e. B, Mg, Ca, Senior, Ba, Ra.
What is the law of definite proportions?
The law of definite proportions says that a substance always contains the same proportions of each element of which it's composed. For example, a molecule of water, H2O, always contains 2 hydrogen atoms for every oxygen atom. This is commonly understood among modern chemists. But it was an important step in working toward a microscopic understanding of the composition of matter. The first to make such claims, in the early 1800s, was the French chemist Joseph Proust. It was a controversial idea at that time. And other chemists believed that elements could be combined in any proportion.
Why do helium balloons float?
Helium balloons float because helium is less dense than air. So gravity pulls down on air more than it does on the helium balloon. The difference in density is enough that the displaced air supports the weight of the balloon and makes it float, up, up, and away.
What is nuclear magnetic resonance, NMR, spectroscopy?
Nuclear magnetic resonance spectroscopy is a type of spectroscopy that involves nuclei in a magnetic field absorbing and re-emitting radiation.
How does materials science help to keep your home warm in the winter?
By designing effective ways to insulate your home, of course. In total, 48% of the energy used annually in the US is spent on heating buildings during the colder seasons and keeping them cooled during the warmer seasons. Insulation materials help to maintain the temperature differences inside and outside of buildings. In addition to polystyrene and other types of insulation, materials to seal window panes and other potential leaks can significantly reduce the amount of energy we need to spend on heating and cooling.
What is an active site?
Each enzyme has an area called the active site in which catalytic activity is carried out. The active site is shaped in a way that reduces the energy barrier to carrying out the chemical reaction it is meant to perform. It's important to note that, while the reactant, S, must bind at the active site initially, they must also be released after the reaction has been carried out.
What are some chemical reactions that we can observe with our naked eye?
There are lots of chemical reactions that we can easily detect by sight. Some examples are the formation of rust on metal, wood burning, fireworks exploding, silver becoming tarnished, or baking soda and vinegar reacting with one another.
What is the Avogadro's number?
The number of particles in 1 mole, 6.022 x 1023.
What are meteorites?
Meteorites are chunks of material, such as giant rocks, from the solar system that manage to make it to the ground as a larger meteor passes through the atmosphere. Meteors entering from outer space pass through the atmosphere at extremely high rates of speed, from 15 to 70 kilometers per second, and tend to mostly burn up in the process. As they pass through the atmosphere, they may be visible from the ground as a streak of light. And this is what is commonly known as a shooting star.
Why did Paul Berg, United States, win the Nobel Prize for Chemistry?
For his fundamental studies of the biochemistry of nucleic acids, with particular regard to recombinant DNA, and Walter Gilbert, United States, and Frederick Sanger, United Kingdom, for their contributions concerning the determination of base sequences in nucleic acids. Berg earned the prize for having been the first to design a recombinant DNA molecule, which is to say he constructed a DNA molecule containing parts of DNA from different species. Gilbert and Sanger shared the other half of the award for their work toward the sequencing of DNA. The sequencing of DNA was initially an extremely time-consuming and expensive task. But today it is becoming more and more feasible to sequence DNA efficiently and affordably.
What's a solvent?
In chemistry, a solvent is a liquid, though it can be a gas or a solid. But forget about that for now, that other chemicals are dissolved in. These other chemicals can be called the solute. The solute and the solvent can together be called a solution. Take salt water, water is the solvent, salt is the solute. And we can refer to the salt water as a solution.
What is a kilogram?
Standard base unit of mass.
What is precipitation?
The process through which a substance comes out of solution, usually due to insolubility.
What determines which metals can be magnetized?
Chemists discuss magnetism in terms of three basic categories: diamagnetism, paramagnetism, and ferromagnetism. Diamagnetic materials have all of their electrons arranged in pairs, which, by definition, means that their spin magnetic moments must all be arranged in pairs and thus cancel each other out. For this reason, diamagnetic materials cannot be magnetic, and won't be influenced by magnetic fields. Paramagnetic materials have unpaired electrons, but in these materials the electrons spin magnetic. Moments cannot all be lined up in the same direction, which means that they cannot be strongly magnetic. Since they do have unpaired electrons, they can be influenced by applied magnetic fields, but not to the same extent as the third class, ferromagnetic materials. Ferromagnetic materials are the materials that can give rise to the magnets we're all familiar with. All of the materials that magnets can interact strongly with are ferromagnetic. In these materials, there are unpaired electrons whose magnetic spin can all be aligned in the same direction. Note that just because a material is ferromagnetic doesn't mean it must be a magnet, but rather just that it has the potential to be magnetized. Take a paper clip, for example. When you first pick it up, it's not a magnet, but you can turn it into a weak magnet by holding a magnet next to it for a short length of time. Some of the most common ferromagnetic substances are those made of iron, nickel, or cobalt.
What is a lipid bilayer?
Lipids are important in cells as they form bilayers that protect the cells and hold them together. In a lipid bilayer, the nonpolar tails gather on the inside of the bilayer, allowing the polar ends of each lipid molecule to interact favorably with the polar, aqueous environment of the cell and its surroundings. Within a bilayer, the lipid molecules can still slide around, and can even flip from one side of the bilayer to the other. Lipid bilayers generally don't allow molecules or ions to pass readily, allowing for the buildup of concentration gradients between the cell and its surroundings. Lipid bilayers are also found elsewhere, for example. They can also form separate compartments within cells.
What is diamagnetic?
A material that creates an opposing electric field in response to an applied electric field.
Are all the carbon-carbon bonds in benzene the same length?
Yes, but you might not think so by looking at a single line structure of benzene. The actual structure of benzene is a combination of two structures, shown below.
What is the rate determining step of a reaction?
In a reaction with multiple steps, the rate determining step is the slowest step. It's the step that limits the rate of formation of the final products. Usually because it has the highest activation energy.
What is DDT?
DDT, or dichlorodiphenyl trichloroethane, is a substance that was widely used as an insecticide until its harmful effects on human health and on wildlife became known. DDT was essentially poisoning the humans and wildlife who came into contact with it. In the context of the advent of green chemistry, DDT carries a special significance in that it helped to awaken the public to the fact that the indiscriminate use of chemicals was causing harm to the environment. News of the harmful effects of DDT was spread by Rachel Carson's 1962 book, Silent Spring, which explained the numerous negative environmental effects of spraying DDT on crops. Knowledge of the harmful effects of DDT helped to awaken the public to the idea that releasing large amounts of relatively untested chemicals into the environment was potentially causing damage to humans and wildlife. DDT was officially banned in the US in 1972.
What is electron capture?
Electron capture is a process that involves an electron combining with a proton to form a neutron. This decreases the atomic number of the element by 1 and leaves the atomic mass unchanged.
What chemicals are typically analyzed in a urine analysis?
Just like a blood analysis, there are several analytes that can be looked at by urine analysis. pH, density, proteins, glucose, ketones, leukocytes, blood, or human chorionic gonadotropin, the presence of which can indicate pregnancy. The results can indicate several things about a person's health. If the person is well hydrated, for example, a lower density would be expected. The presence of proteins in the urine is uncommon, and this may indicate that the patient's kidneys are not functioning properly. Similarly, glucose and ketones should not be present in the urine. But if they are, their presence could be a symptom of diabetes.
What makes carbon monoxide dangerous?
When carbon monoxide is inhaled, it is readily absorbed through the lungs and into the Bloodstream where it binds to the phase center in hemoglobin, see also biochemistry. Unfortunately, hemoglobin binds to carbon monoxide much more strongly than it does to oxygen. So carbon monoxide rapidly interferes with the ability of hemoglobin to deliver oxygen throughout your body. If this happens, then your muscles and your brain will begin to run out of oxygen. Similar to what happens when a person is drowning. Carbon monoxide is a colorless, odorless gas, which makes it difficult to detect unless you have a carbon monoxide detector around. Carbon monoxide levels of 100 parts per million or higher can be hazardous or fatal to humans. Poisoning from carbon monoxide can result in brain damage. Damage to the endocrine system, to the nervous system, and to the heart and other organs. It represents the leading cause of accidental poisoning-related death and poisoning-related injury globally. We should mention that even if a person survives carbon monoxide poisoning, there may be long-lasting effects. Early symptoms of carbon monoxide poisoning can include headaches or nausea. And the treatment for carbon monoxide poisoning typically involves having a person breathe 100% O2, recall that air only contains Ca. 20% O2, so that O2 can more competitively bind hemoglobin to replace carbon monoxide.
What is an addition polymerization reaction?
The easiest way to describe an addition polymerization reaction is that monomers are bonded together without the loss of any atoms of the monomer. There are more complicated ways to classify this type of reaction based on kinetics. But it essentially boils down to this fact.
What is the intensive property?
A property that does not depend on the amount of a substance present, e.g., density, temperature, color.
What is a gel?
Gels are solid materials that have flexible properties, but do not actually flow in the same way that liquids do. They are made from a cross-linked bonding network of atoms, which actually contains a majority of liquid-like molecules interspersed by weight, but it still behaves as a solid. The cross-linked network within the gel gives it its solid-like properties, while the fluid component gives the gel its stickiness.
A part of my brain is called the pons?
Yes. The pons is located in the brain stem, and its function is to move information between the cerebellum and the cerebrum.
What is a cation?
A cation is a positively charged atom or molecule. Cations have a larger number of protons than electrons, such that they have a net positive charge.
How can I use chemistry to make dull pennies shiny?
Chemistry principles encountered in this experiment: surface chemistry, oxidation reactions, materials you'll need. A handful of dull pennies, 10 will do, 1 teaspoon table salt, sodium chloride. 1/4 cup white vinegar, acetic acid solution, a small, non-metallic bowl, water, paper towels or napkins. The procedure: pour 1/4 of a cup of vinegar and 1 teaspoon of table salt into the bowl. Stir the mixture until the salt is completely dissolved. Try first dipping 1 penny into the solution for about 15 seconds and remove it.
What is polarity and how is it related to molecular structure?
Polarity is related to the symmetry of the arrangement of electron density in a molecule. Polar molecules are those which possess a net dipole moment, which means that the electron density is not symmetrically distributed in all directions. Nonpolar molecules have the electron density distributed in such a way that there is no net dipole moment. Typically, this doesn't mean that nonpolar molecules have their electron density distributed evenly over every part of the molecule, but rather that the dipole moments created by an unequal sharing of electrons in each individual bond cancel each other out, so that there is no net direction in which an asymmetry of electron density exists.
What is an elastic material?
A material that deforms when an external force is applied, but returns to its original shape when the external forces are removed.
What is heat?
Transfer of energy between substances with different temperatures.
How does non-stick cooking spray work?
It's not nearly as magical as you might think. Cooking spray is just regular vegetable oil in spray form. To get it to spray out a fine mist, an emulsifier is added, and the can needs something to act as a propellant, usually alcohol, CO2, or propane.
What is the pH of an aqueous solution?
The pH of an aqueous solution provides a description of the concentration of H3O and ions, or water molecules that have accepted an extra proton, in the solution. The pH is calculated as the negative logarithm, base 10, of the activity of H3O and ions in solution. A pH near 7 indicates that the solution is nearly neutral, in the sense that this would be the pH of pure water without any acid or base added. A pH value lower than 7 indicates that the solution is at least somewhat acidic, while a pH above 7 indicates the solution is basic.
Do pesticides make food more dangerous?
Pesticides certainly don't help make food safer, but their adverse long-term effects are difficult to measure. Limiting exposure as much as possible is certainly a good idea.
What is a reversible reaction?
A reaction where the products can be converted back into the reactants.
What is a racemic?
A mixture of equal amounts of the two enantiomers of a chiral molecule.
What is radiation?
The emission of energy as an electromagnetic wave.
How can reactions be run in a solvent-free environment?
There are a few common ways to avoid the use of solvents when running a chemical reaction. The simplest situation is when one of the reagents can serve as the solvent for the reaction. This is commonly referred to as running a reaction neat, yes, like Scotch. Reagents that are not liquids at ambient temperatures can also be used in the molten state so that they can be used as solvents. Some reactions can also be run on solid supported catalysts that do not require a solvent. By avoiding the use of solvents, each of these approaches cuts down on costs and on the amount of waste generated.
What is an electrophile?
A species that is attracted to electron-rich atoms or molecules.
How does fertilizer work?
Fertilizers are used to get elements that plants need into the soil. When the natural environment doesn't provide sufficient quantities. The typical elements are nitrogen, N, phosphorus, P. potassium, K, calcium, Ca, magnesium, Mg, and sulfur, S. They're actually labeled by the elements they contain. Next time you're at a garden store, look for NPK or NPKS on a bag of fertilizer. The numbers after these codes tell you the weight % of these elements in the bag.
What is ionization energy?
Energy required to remove an electron from an atom or ion, i.e., ionization potential.
Why did Osamu Shimomura, Japan, Martin Chalfie, United States, and Roger Y. Cien, United States, win the Nobel Prize for Chemistry?
For the discovery and development of the green fluorescent protein, GFP. These three scientists received the prize for their work. With the protein simply called green fluorescent protein, or GFP. This protein was first observed way back in 1962 in a jellyfish. It eventually became a very important molecule in the biological sciences. As clever researchers have found ways to use GFP to study otherwise invisible chemical processes. Shimomura, Chalfie, and Cien were at the forefront of the major discoveries that led to the understanding of GFP that researchers possess today.
Why did John B. Fenn, United States, and Koichi Tanaka, Japan, win the Nobel Prize for Chemistry?
For the development of methods for identification and structure analyses of biological macromolecules. For their development of soft desorption ionization methods for mass spectrometric analyses of biological macromolecules, and Kurt Wuttrich. Switzerland, for the development of methods for identification and structure analyses of biological macromolecules for his development of nuclear magnetic resonance. Spectroscopy for determining the three-dimensional structure of biological macromolecules in solution. In the past, mass spectrometry was limited to the study of relatively small or lightweight molecules. Fenn and Tanaka share half of this prize for their work in extending the technique of mass spectrometry to significantly larger biomolecules. Fenn and Takana independently developed two different methods for obtaining freely hovering protein samples appropriate for mass spectrometric analysis. Wuttrich received the other half of this prize for the use of NMR spectroscopy to determine the three-dimensional structure of biomolecules in solution. This represents a significant advance beyond crystal structure analyses, as the structure of biomolecules may differ in the crystalline and solution phases, with the solution phase structure being more relevant to their true biological function.
Who first realized that air has weight?
It was actually a mathematician named Evangelista Torricelli who is the first on record to demonstrate that air has weight. His experiment to prove this fact was prompted by the observation that water from a mineshaft could only be pumped upward to reach a certain height. Torricelli thought that the air pushing down on the surface of the water must play a role. To test this theory, in 1643 he placed a sealed tube of mercury upside down in a bowl of mercury. He observed that the weight of the air would keep the mercury in the tube at a certain level. And on different days he observed that the mercury would rise to different levels. We now know this is because the air pressure varies from day to day. And Torricelli's experiment was the first barometer.
Why did Richard Martin Willstetter, Germany, win the Nobel Prize for Chemistry?
For his researches on plant pigments, especially chlorophyll. Willstetter was a German organic chemist who studied a variety of pigments isolated from flowers and fruits. He was the first to show that chlorophyll was a mixture of two different compounds, known today as chlorophyll A and chlorophyll B. These two molecules absorb slightly different wavelengths of light, so that the plant can capture more of the sun's energy.
What is biodiesel?
Biodiesel is a type of fuel made from vegetable oil and or animal fat which consists of long alkyl esters. See Organic Chemistry to review functional groups. Biodiesel fuel is commonly distributed for sale as a mixture with petrodiesel, and is labeled with a B factor describing the fraction of biodiesel present. B100 is pure biodiesel, while B20 would represent a mixture of 20% biodiesel with 80% petrodiesel.
What is a ligand?
A group, an ion or a molecule, that coordinates to a metal atom, forming a coordination complex.
How are herbal medicines prepared?
There are many ways of preparing herbal medicines. Tinctures and elixirs are extract ions of herbs using some solvent, usually ethanol. If a plant is extracted with acetic acid, the solution is known as a vinegar, even though the solvent is also vinegar. A tisane uses hot water to extract herbs like tea.
What is a cell?
Cells are basic structures that make up all living things. The smallest organisms, like bacteria, can be made up of only a single cell. These are known as single-celled organisms. Other organisms, like animals or humans, are made up of many, many cells. The size of a typical cell is very small, usually on the scale of 10 to 4 or 10 to 5 meters. This is small enough that we can't see it with our eyes, but only under a microscope where cells are readily visible.
What is the Air Quality Index, AQI?
The Air Quality Index, or AQI, is a measure describing the amount of particulate matter found in the air. Since this value can vary significantly over short periods of time, the AQI is typically reported for a given city at least once per day. The higher the AQI value, the greater the associated health concerns. Since a few different measures exist out there for characterizing the air quality, we will spare you the details of exactly how the number is calculated. It is worth paying attention to the AQI when you are considering traveling or relocating to new places. Some large cities have developed major ongoing problems with their air quality. And looking at a city's recent AQI history is a useful indicator of the air quality you can expect to find. The table below summarizes relevant ranges of AQI values used in the United States and their health implications.
What causes acid rain?
Similar to smog, acid rain is caused by chemical reactions of pollutants like sulfur dioxide and nitrogen oxides with oxygen and water in the air. The acidic pollutants formed in these reactions are the cause of acid rain. In addition to environmental pollution due to human activities, volcanic activity can also cause acid rain. Acid rain can be harmful to natural plant life, farm crops, animals, and marine life. It can also be damaging to buildings, depending on what materials were used in their construction.
What is a glass?
A glass is a non-crystalline solid. It lacks order in the solid state. In polymer chemistry, scientists are concerned with the glass transition temperature, Tg, which is the temperature at which a material changes from a hard to a rubbery state. What's neat about this transition is that the material is not changing phases, i.e., from solid to liquid, but is changing from one type of solid to another.
What chemicals are produced on the largest scale?
In terms of volume, not profit, sulfuric acid is the largest chemical produced worldwide. Global consumption is around 200 million tons per year, a number that is just too impossibly large to imagine. nitrogen, N2, ethylene, CH2CH2, oxygen, O2, lime, mainly CaO, and ammonia, NH3, round out the top 5, though sometimes these change.
Are hydrocarbons always straight chains of carbon atoms?
No. There could be carbon atoms attached to the linear chains we talked about in the previous question. Let's learn the next step in naming alkanes and have a look. First, we need to define the names of branches. See graphic, next page. Chemists use the same prefixes to indicate the length of the branch. But now the suffix is YL instead of ANA. So methane, CH4, when it's a branch off of a chain of carbon atoms, becomes methyl, CH3, ethane, CH3CH3, becomes ethyl, CH2CH3, and so on. Next we have to indicate where along the main carbon chain the branch point is. This part is pretty simple, just number the carbon atoms and put this number before the name of the branch. So if you had an 8-carbon chain, octane, with a 2-carbon branch, ethyl octane. On the third carbon from the end, it would be called 3-ethyl octane and look like this. There are a lot more rules to naming organic compounds, but that's enough for now.
What makes hot peppers so spicy?
The molecule that makes hot peppers so spicy is called capsaicin, see its chemical structure below. This molecule behaves as an irritant to humans and other mammals. But some of us still really like its flavor.
What is a polydentate ligand?
A polydentate ligand is a ligand that coordinates to a metal center via 2 or more atoms, forming 2 or more bonds. This resulting complex is known as a chelate complex.
How do chemists name so many different hydrocarbons?
With a bunch of rules. Let's start with just straight chains of carbon atoms. Here we just need to define how many carbon atoms there are in the molecule. If the molecule doesn't have any double bonds, we use the suffix -ana. The prefix indicates how many carbon atoms there are. Most of these prefixes are based on Greek numbers, one is Latin, and a few are just weird. Collectively, these molecules are called alkanes.
How are polymers different than small molecules?
So many ways. Polymer chemistry and polymer physics are big areas of research both in the recent past and today. Because connecting a bunch of small molecules into one big one results in lots of interesting changes. To give you a metaphor, let's talk about pasta. Start with uncooked macaroni and uncooked spaghetti. If you try to move your hand through a bowl of uncooked macaroni, you won't have much trouble. But if you had spaghetti noodles all lined up and you tried to move your hand through them, in either direction, you'll run into problems. You either need to break the noodles, or you need to carefully thread the noodles through your fingers. Both of these actions require energy, enthalpy in the first case and entropy in the second. Now let's cook those noodles. Stick a fork in each of the bowls and spin it around. With macaroni, nothing happens, but the spaghetti starts to wind around your fork, gets tangled up, and so on. Macaroni, a collection of small molecules, noodles, is totally different than polymers. Spaghetti, which are also made up of flour and water, but are much longer. The raw and cooked spaghetti aren't just easy to imagine. They're great ways to think about polymers in different states, solids and liquids, glassy states, and polymer melts.
Why do old library books begin to smell after sitting on shelves for years?
The smell of old books is due to hundreds of volatile organic compounds that form from the slow degradation of the book's paper and other materials used in its construction. Acetic acid, vinegar, and furfural, smells like almonds, are two common chemicals ascribed to the smell of old books. Scientists can analyze the volatile compounds to identify the materials used without having to destroy a part of the historical document.
What makes strong acids and bases dangerous to work with in the laboratory?
Strong acids, like nitric acid, are strong oxidizing agents and can cause severe burns on your skin. Strong bases, like sodium hydroxide, can also cause burns as well as nerve damage. Strong acids and bases destroy your cells by reacting with the membranes, proteins, and other components that make up your cells. They are also dangerous to your eyes and can permanently damage your vision.
What is an isochoric process?
An isochoric process is a process that takes place at a constant volume.
How does radioactive dating work?
Radioactive dating, also called radiometric dating, is a technique used to determine the age of a sample based on the ratio of isotopes of an element present in the sample. Using the known half-life of the isotope being studied, along with knowledge of the natural abundance of the isotopes present at the time the sample was formed, the age of the sample can be determined. To obtain an accurate age for a sample, it is required that none of the isotopes being measured have been able to escape or re-enter the sample over the course of its lifetime. Otherwise, this could serve to establish a ratio of isotopic abundances that is not representative of that based purely on the half-life of the isotope whose decay is being measured.
What is aromaticity?
Aromaticity is a special kind of resonance delocalization, one we've actually already seen. Delocalization of electrons always makes molecules more stable compared to imaginary molecules where the electrons cannot spread out. If this delocalization takes place in a flat ring of n carbons, and the number of electrons involved is 4n plus 2, i.e., 2, 6, 10, 14, etc., then the system is called aromatic.
What is aerogel?
Aerogels are materials that are very similar to normal gels, except for the key detail that the liquid component has been replaced with a gas. Since liquids were such a large component of gels by weight, aerogels are very lightweight. This type of material is translucent and has been given nicknames like solid smoke or solid air. It is produced by extracting the liquid component from a gel using a process called supercritical drying, which allows the liquid to be evaporated away without causing the solid network of chemical bonds to collapse. Aerogels have been produced from a variety of materials including alumina, silica, chromia, and tin dioxide.
What is a covalent bond?
The equal, or near equal, sharing of electrons between two or more atoms.
Why did Archer John Porter Martin and Richard Lawrence Millington Singh, both United Kingdom, win the Nobel Prize for Chemistry?
For their invention of partition chromatography. Martin and Singh won the prize for their development of the basic principles of chromatography, or the separation of chemical substances based on differences in their chemical properties, often their polarity. In their separation method, a drop of a mixture of compounds is placed on a strip of paper, and a solvent, perhaps water or an alcohol, or a mixture, is drawn up the strip of water, resulting in a separation of the compounds in the mixture. This separation occurs because each component in the mixture interacts differently with the solvent. This method has been expanded upon by a large number of later researchers. And chromatographic methods play a very important role in laboratory chemistry to this day.
What is the mobile phase in chromatography?
The mobile phase is the vaporized sample in gas chromatography or the solvent used to elute the sample over the stationary phase in liquid chromatography.
Why did Ernest Rutherford, United Kingdom, New Zealand, win the Nobel Prize for Chemistry?
For his investigations into the disintegration of the elements and the chemistry of radioactive substances. Rutherford's most famous experiment, the gold foil experiment, was actually done after he received the Nobel Prize. He was awarded the Nobel for discovering that there were multiple kinds of radioactivity. He named them alpha and beta rays. Why did later he added gamma rays to the list? And for proposing that radioactivity was a result of the atom actually breaking apart. Until Rutherford's work, chemists had assumed that atoms were indestructible.
What is diffraction?
Change in the direction of a wave caused by an obstacle, be it a wall, or a nucleus.
What is an excited state?
An atom or molecule in any electronic state of higher energy than its lowest energy state.
Why is ultraviolet light from the sun potentially dangerous?
Most of us like being out in the sun, but we've also all heard to be careful not to get sunburned, since too much sun can cause serious problems like skin cancer, along with less serious problems like wrinkles and dry skin. The sun can damage your skin because the ultraviolet rays from the sun are relatively high energy photons that can damage the elastin fibers in your skin. These can then lose their ability to go back to their original position after they are stretched, and also lose their ability to heal as quickly when wounded or bruised. As we discussed briefly in biochemistry, the cause of cancers generally involve damage to the genetic material, DNA, of your cells, which interferes with their ability to replicate, or stop replicating, normally. With regard to cancers arising from too much exposure to ultraviolet radiation, DNA can be damaged in two ways. The first, probably more obvious, route is that the ultraviolet radiation could be absorbed by the DNA directly, causing changes in its chemical structure. The second possibility is that ultraviolet radiation can be absorbed by other molecules first, forming reactive, damaging radical species. like hydroxyl radicals or singlet oxygen, which then diffuse through cells and can damage DNA.
How do you measure conductivity of a solution?
Conductivity describes the ability of a solution to conduct an electric current. There are a few methods for measuring the conductivity of a solution. And the most straightforward to understand is probably the amperometric method. This method simply applies a voltage between two electrodes and measures the current. While this method is simple to describe, it can have complications in practice and it isn't always the most accurate method. Another way of measuring conductivity is with a potentiometric method, which makes use of two pairs of rings. There are two outer rings that apply an alternating voltage, and this results in a loop of current being generated in the solution. The other pair of rings sits inside the first and measures the change in voltage between the pairs of rings. This change in voltage is directly related to the magnitude of the current loop induced by the outer rings, which is in turn directly related to the conductivity of the solution. Other methods exist to measure conductivity, but these are probably the easiest to both describe and understand.
Do you notice a change in the part that you dipped into the solution?
Place the remaining pennies into the solution. You will likely notice a visible reaction as the pennies are placed in the solution. The reason pennies eventually begin to appear dull is that the copper surface reacts with oxygen in the air to create a layer of copper oxide. In this experiment, the vinegar and salt will react with the copper oxide and remove it, which will leave a layer of the original shiny copper exposed on the surface. Allow the pennies to remain in the solution for several minutes. If necessary, try to move the coins around so as to expose both sides of each coin to the solution. If possible, flip the coins over after a couple of minutes. Drain the solution and rinse the coins with clean water. They should now look clean and shiny.
Why did Ernst Otto Fischer, Federal Republic of Germany, and Geoffrey Wilkinson, United Kingdom, win the Nobel Prize for Chemistry?
For their pioneering work, performed independently on the chemistry of the organometallic, so-called sandwich compounds. Fischer and Wilkinson received the prize for their role in elucidating the basic properties surrounding bonding and reactivity in organometallic complexes, with a particular focus on their work with organometallic sandwich compounds, which involve a metal center sandwiched between two ligands. This prize was somewhat special in that it was openly recognized that the practical implications of their work were not readily obvious, but that the knowledge surrounding organometallic Chemistry gained from their work would be invaluable to chemists in the future. Why did Paul J.
What is a nonmetal?
An element that does not possess the properties of a metal.
What's in self-rising flour that makes it rise?
Baking powder and salt are added to flour to magically transform it into self-rising flour. Yeah, not so magical after all.
What is the meniscus?
A phase boundary, which is curved due to surface tension.